Welcome to Mathy Python episode 11, Working with Files. Every program we've written so far lives entirely in memory. The moment the notebook closes, the data is gone. Today we look at how to read data from files and write results back to disk. This is a bridge between toy examples and real work. Real data lives in files. Opening and reading a file. So we have the notebook file here. We can see on the left, we have data text, which is just some text. Python is a general purpose programming language, etc. We have a CSV file that we will use later in the episode. This is how a spreadsheet might look at it. Under the hood, this is comma separated values, CSV, so-called because there are values and they are comma separated. So name, score, and grade, that's the header. Alice, score of 92, grade of A, etc. Okay. So let's open up one of those files. So first I'll create what's called a file handle, which is just a name for Python to refer to that file. So I'll call it F for file. And R, there are other options we'll see here in a moment. Then we'll do something with the file. So contents is F, our file, and then we'll read it. And yeah, then we'll print the contents, and then we'll close the file. So you need to close the file to clean up after yourself. Okay, so it opened that data file that we just saw, this. Then it prints it out, then it closes the file. The R is the mode for read. So you're opening the file just to read the file. You can't write to it. You just want to read the file. Forgetting to close the file is a common bug. It might not hurt anything, but it does leave you open for the file to accidentally get corrupted or overwritten or something. So it's good practice to always close it. There's another way to open files that will automatically close it for you when you're done, and that is a with block. So I'll say with open data.text R as F. So this is roughly equivalent to the top line here, but it also creates this block. So when we come out of the block, the file will automatically close. Then we say contents is F read. Contents is in memory. I don't need the file handle anymore. So I can print contents. When the with block ends, Python closes the file for you, even if something goes wrong inside of the block. With is a lot safer, so I'd recommend you use the with. Why bother to close files? Doesn't Jupyter or Python or the operating system do it for you? Well, there's a few reasons. One is buffering. So Python does not always write data to disk the moment that you call write. It often holds data in a buffer in memory first for efficiency, and then flushes that buffer to disk when the file is closed. If your program crashes or exits before the file is closed, that buffer data can be lost. You thought it was written, but it never made it to disk. File handles are a limited resource. When you open a file, the operating system gives your program a file handle, which is a reserved connection to that file. The operating system keeps track of how many handles are open at once, and there is a limit, typically in the hundreds to low thousands per process. Leave enough files open without closing them, and you hit that limit, at which point open starts raising errors, even though none of those files are actually in use anymore. In toy programs, like we've seen in this lecture, that's not an issue. But in a real program, you might have tons of files being opened and closed, so you need to do that. The third reason is the operating system itself. So the operating system does clean up open file handles when a process exits completely. For a short script that runs and finishes, leaked handles are usually not a problem. But in a long-running program, a server, a data pipeline, anything that processes many files in a loop, unclosed handles accumulate. That is where the data loss risk becomes a real risk to be mitigated. So, two solutions. One, always close your file. That's really easy to forget. It's easier to forget than you might think. So, the other solution is to always use with. So, the with closes the file the moment the block ends, guaranteed, without you having to remember or do anything else. Also, visually, it just makes it clearer that this is happening with a particular file. So I think it's a good visual clue. It's good for readability. You can read a file line by line. So Python gives you a few different ways to read a file. So let's look at them in order from most granular to least. So read line, singular, reads one line at a time. So let's say with open our file, give it a file handle. So open data.txt for reading as F. F is our file handle. Line 1 is F.readline. Line 2 is F.readline, the next line. Line 1 and 2 are in memory. I don't need the file for that anymore. So I'll jump out of the block, print line 1, print line 2. So each call to read line advances through the file one line and returns it as a string. Call it again, and you get the next line. This is useful when you want fine-grained control over how much you read at a time. Read lines, plural, reads the entire file in one go. So this is useful when you need to jump around or process lines out of order. So for instance, we could open our file. And then for each line in that file, let's print it out, but let's strip all the space around it. You can loop over a file object directly without calling any read method at all. Python hands you one line per iteration. This is the most memory efficient option for large files since it never loads the whole thing in the memory at once. So comparing what we've learned so far, readline singular returns one string, does not read the file all at once. Readlines returns a list of strings. It does read all at once. And to iterate over, you say for line in F, it gives you one string per iteration. Writing to a file. Python has three main file modes worth knowing. You've already seen R, which is strictly for reading, not writing. W is for write. So it creates a file if it doesn't exist. It overwrites it if it does. So careful with this if you don't want to overwrite the file. So output text. W. Let's read that in as F. A little sloppy here. Let me There we go. Then we'll write some text. I'll say Mathy Python. Okay. So we opened the file output text. This is strictly for writing. It will give us the file handle F so that we can refer to it. Then we will write. I don't know why my indentation was so aggressive. We will write a piece of text to it, and then another piece of text to it. Close my parentheses. There we go. Now we see output has appeared here, and it has those two lines. If I then say Mathy Python is the channel, is the latest, and I rerun it, we look at output, we see the previous output has been blown away, and then this new output has completely overwritten the file. So that's good when you want to blow away your old file and have some new input. So use W when you are generating fresh output file every time your script runs. So anywhere you want to start clean each run. The overwrite is silent. There's no warning. There's undo, no undo. So be intentional about when you reach for this. You can also append to a file, which means that you are writing to the end of the existing file. So now I could say with open, oh my goodness, open output.text for appending. And I will write a line that says added this line. We look at the output and we see that the line added this line has been added. Use R whenever you're only reading. It's the safe default. Python will raise an error if you try to write to a file opened in read mode, which is exactly the kind of guardrail you want when you don't intend to change anything. Okay, let's look at the CSV file again. Remember the CSV that gives you a table, kind of like a spreadsheet table under the hood. It's really comma separated. So let's say with open, we'll open that CSV, which is called score CSV. Open it for reading only. Read in the whole file as a list. Then we'll say our header is the first line. Let's strip all the space out. Split it on the comma. Print the header. So now we will iterate through the rest of the file. So line 1, which is the second line, through to the end. And the fields, as our line. Let's strip out all the space. Let's split it on the comma. Name will be the first field. Score is the integer from fields 1. The score is the entry at index 0. And then we'll print that out as an F string. So we'll print out the name, the score, and the grade. All right, so first I printed out the header, which was line sub 0. You can see it's a list. Then 4 line in the rest of the lines. Read the line, strip out the space. Name is the first field. The score is the integer of the field at index 1. The grade is the field at index 2, and then print it out. This is the manual approach. In practice, once we get the pandas, we'll read a CSV in one line. But this is good to understand what's happening under the hood and splitting strings and parsing fields, iterating over rows. All that stuff is what the library, data library pandas is doing internally. So it's worth seeing it once. If you want to see how to read a file in using pandas, I have a video on that, which I will link in the description. Let's look at file paths. So far, we've just been using file name. That works when the file is in the same directory as your notebook. But what if it's somewhere else? So let's create a new folder, call it data. And then I'm going to move my data files into data. So if I go within that directory, I can see that's now where these data files live. This is a typical way to set up your project so you don't have everything in one root directory, which is hard to read, keeps things organized, to put data in data. So now to open that, I say with open, first the folder name, then the file name. Open this up for reading. File handle, call it F. Contents, f.read. Print out the contents. There they are. Forward slashes work on all platforms in Python, including Windows. Backslashes are Windows only and cause headaches. So use forward slashes. For anything more involved in this, the pathlib module is the modern way to handle file paths. We'll talk about that in a later episode when we talk about the standard library. Handling errors. If you try to open a file that doesn't exist, you'll get an error to that effect. So let's say with open missing.txt. Then I'll say contents is f.read. I'm trying to read from a file handle that does not exist because the file does not exist. And if I do this, I get a file not found error. It's exactly what it says it is. No such file or directory as missing.txt. We'll see how to handle errors gracefully in a later episode of this series. There is a way to handle errors so that you don't just get an ugly error message and your program dies. And we will see how to do that. It's using something called a try except block. Reading and writing files, line by line processing, looking at a CSV, file modes, and paths. That's what we covered. Real data lives in files, and now you know how to get to it. Next episode, we'll talk about imports and the standard library. There are a lot of tools that ships with Python that you don't need to install separately. So we'll see how to get to all of that stuff. Link to the GitHub page where the notebook lives is in the description. If you like the content, please subscribe. Happy programming.